Yo, continuing on with August 2015 Chemistry Regents Part 2 questions, or really Part C, written response questions. All right. So check out this. It says questions 58 and 59 are based on the information below and your knowledge of chemistry. Okay. So it says a sample of a substance is a liquid at 65 degrees Celsius. The sample is being heated uniformly up until 125 degrees Celsius. The heating curve for the sample at standard air pressure is shown below. All right, so this comes back to heating curves or cooling curves, both. Okay, so let's, quick check. The y-axis is temperature in degrees Celsius. Great. Since the substance is being heated uniformly, the x-axis is just time going on. So basically, this is as if you had taken a liquid and you put it on a pan in your kitchen and you set the flame to a certain level, and that's it. You leave it. So constant heating. Okay, so this is what I do when I'm looking at a heating or cooling curve. They stated that the substance starts off as a liquid. So this bottom leg here from A to B, that section, I'm going to put an L to label it as liquid. Now, if you notice from B to C, which is occurring at a temperature of 95 degrees Celsius at standard air pressure, the temperature is not changing. And if you remember learning this, that's because, the liquid is evaporating or boiling into a gas. And when a substance is undergoing a change of physical state or phase, whatever you want to call it, state, phase, same thing, the temperature does not change. So while water is boiling, the temperature stays at 100 degrees. When butter is melting, the temperature stays constant. All right, so remember that when you see the temperature staying constant, something is happening. You're either having a change of liquid to gas, which is evaporating, like in this case, or you could have gas back to liquid, which is condensation, solid to liquid, melting. It doesn't matter. If the temperature stays the same while heat is being either removed or added, something is changing state. So in this case, we know now that you have a liquid evaporating at 95 degrees or boiling at 95 degrees. And eventually you get the gas to go up to 125 degrees Celsius. The thing is, this is easy. They only asked us for the boiling point. So the answer is 95 degrees Celsius. That's it. Okay. Now, the next question, 59, says, state what happens to the potential energy of the particles of the sample during time interval B to C. Okay. So actually, I'm going to, you know what? I'll just use a different color. No, I'll ditch all this. Here, delete. Okay. So now we know we have liquid turning into gas, all gas. Okay. Now let's go back to temperature, which is actually average kinetic energy. Okay. Temperature is the measurement of average movement, which is kinetic energy in a sample. And you have to remember that it's the average because some atoms are shaking more than others. Anyway, when you see the temperature increasing, like from A to B, that means that the average kinetic energy is increasing. If you're adding heat to a sample of something, in this case a liquid, if you're adding heat, but the temperature is not changing, that means that you must be adding, the heat must be doing something else. And in this case, you're adding heat. It doesn't look like it's doing anything. Well, it is doing something. You're seeing your liquid evaporate or boil, which means that over here, when a liquid is boiling into a gas, the potential energy is increasing. And then over here again, from C to D, where the gas, the temperature is rising, that means the kinetic energy, again, is increasing right there. That's it. So back to the question, what is occurring to the potential energy of the particles of the sample during time interval B to C? The potential energy of the particles from B to C is increasing. That's it. The potential energy is increasing. And that's from point B to C. There you go.